Welcome to the lecture series on numerical methods. Currently we are discussing interpolation. In the interpolation we have discussed like finite difference operators and like Newton's forward difference formula, backward difference formula and central difference formula. And in the last lecture we have a cover of this Lagrange interpolation formula. So now we will discuss about Newton's divided difference formula. So before going to Newton's divided difference interpolation, first we will discuss about what is divided differences. So divided difference means if you will just have a set of data points like x0, y0, x1, y1 up to xn, yn here. Maybe it is uniformly spaced or non-uniformly spaced, but we can use these divided differences here. So suppose this corresponding values of y in terms of x, if we are just expressing here as y equals to f of x for x equals to x0 to xn here, we can just express this divided difference for this function y equals to f of x as like f of x0, x1 for two consecutive points. We can just write f of x1 minus f of x0 by x1 minus x0. Similarly, if we want to write for x1, x2 for two consecutive points, since whatever these tabular points I have written it off here, that is starting point is x0, next point is x1, corresponding this y values are associated values like y0, y1. So we can just write this first function as also y1 minus y0 by x1 minus x0 here. And for the second two points like x1 and x2, if I want to express in divided difference form, I can just write f of x2 minus f of x1 by x2 minus x1 here, which can be written as y2 minus y1 by x2 minus x1 here. Obviously the question arises that if we are just writing this values of x0 and x1 here in augmented form or in arguments, then how we can just express f of x0 here. So we can just write obviously f of x0 equals to f of x0 as this one, and f of x1, since it all are independent points, we can just write these arguments as the functional values at that points. And if we are just going up to the last of the interval here, that is xn minus 1 to xn here, we can just write this divided difference of xn minus 1 to xn as f of xn minus f of xn minus 1 divided by xn minus xn minus 1, and this can be written as also yn minus 1 divided by xn minus 1 here. So these are all called first order divided difference here, and if you will just go for second order divided differences here, then we can just express the second order divided difference, especially if the points are placed at like x0, y0, x1, y1 up to xn, yn here. At a time, if we are just considering 3 points, suppose x0, x1 and x2, we can just write this divided difference that in the form of second order divided differences, that is f of x0, x1, x2 as f of x1, x2 minus f of x0, x1 divided by x2 minus x0 here. And the third order divided difference, since if you will just see here for second order divided difference we are just considering 3 points, for the first order divided difference we are just considering 2 points there. So if you will just go for third order divided difference here, then we have to consider like 4 points here, x0, x1, x2, x3, and it can be written in the form of like f of x1, x2, x3 minus f of x0, x1, x2 divided by x3 minus x0. And for nth order divided difference, we can just write that one as like nth order. If you will have like n plus 1 values here, x0, x1, 2 up to xn here, we can just write this one as x1 to xn minus f of x0 to xn minus 1 divided by xn minus x0 here. We can just see that if we are just going for this like first order divided difference, we are just using 2 points, and especially that can establish a relationship between these functional values at x1 and x0. And if we are just going for the second order divided difference here, we can just find that this establishes a relationship between, like if again if you will just take these differences here, it can be written in the form of f of x2 minus f of x1 divided by x2 minus x1 minus f of x1 minus f of x0 divided by x1 minus x0 divided by x2 minus x0 here. This means that this establishes a relationship between x2, x1 and x1, x0. And if you will just go for this third order divided difference here, it establishes a relationship between like x0, x1, x2 and x3 combinedly here. The advantage of this method is that in a Lagrange interpolation method, usually whenever a extra point is added there, so we have do all the computations newly. This means that all of these products again we have to consider in a modified form, that the extra point can be multiplied with rest of the factors there. But here if you will just see, this extra point can be added in a uniform way, that extra multiplication is not needed. If we are just seeing these differences here, these arguments are like equal if the divided differences may still have a meaning here. This means that if the arguments are equal, like suppose x0, if we want to write like f of x0, x0 there, this means that if we are just writing f of x0, x1 suppose, where x1 can be written as x0 plus epsilon, where epsilon is very small. This means that we can just consider epsilon tends to 0 here. So then we can just express f of x0, x1 as f of x1 minus f of x0 divided by x1 minus x0. Obviously this is the like first order this divided difference, this formula represents in this form here. But if you will just replace this x1 here in the form of x0 plus epsilon, where epsilon is very small, we can just write this statement as in the form of limit epsilon tends to 0, f of x0 plus epsilon minus f of x0 divided by epsilon here. And obviously this is nothing but f dash of x0 here. So we can just say that here, if the arguments are equal, then the divided difference still produces some value here, and it is in the form like if we are just considering here f of x0, x0, where x1 can be represented in the form of x0 plus epsilon, and epsilon is very small, then it can just represent the derivative of this function at that point only. So if suppose f of x is differentiable, and if we will have this r plus 1 argument, suppose like we can just write f of x0, x0 up to r plus 1 times. We can just write this one as f to the power r of x0 by r factorial. Since if you will just see here 2 points are there, so that is why we are just writing this as f of x0, x0 as f dash x0 here. Similarly, we can just consider that this should be r plus 1 points to get this derivative in the form order of r here. So if we will just go for this divided difference table here perfectly, we can just find that this tabular values like I equals to 0, 1, 2, 3, 4 and its corresponding values suppose x0, x1, x2, x3, x4. Then we can just evaluate this first order divided difference, second order divided difference, third order divided difference to get any of the approximated value within that range. This means that suppose like our earlier computation, if the value is asked to compute within any of the intervals suppose, then we have to use this divided difference in such a fashion that this value can be computed in easy form. So that is why if you will just consider like I as the values as 0, 1, 2, 3, 4 here, the corresponding xi values are x0, x1, x2, x3, x4 here, and corresponding this y values we can just write y as y0, y1, y2, y3, y4 here, or we can just write this one as f of x0, f of x1, f of x2, f of x3, f of x4. And if you will take this first order divided difference here, sometimes also this divided difference is written in this form also. And the first order divided difference, if you will just see, that is just giving you f of x0, x1 here. This means that the difference of these two divided by the difference of these two here. And if you will just take this divided difference of x1, x2 here, that will just give you f of x2 minus f of x1 divided by x2 minus x1 here. Similarly, if you will just consider this divided difference of like x2, x3 here, then we can just consider that one as a f of x3 minus f of x2 divided by x3 minus x2. Similarly, we can just find this divided difference of like x3, x4 as f of x4 minus f of x3 divided by x4 minus x3. And then second order divided difference, you can just find it out here, that is in the form of like f of x0, x1, x2. And then we can just write this one as f of x1, x2, x3 here. And next divided difference we can just write x2, x3, x4 here. Similarly, the third order divided difference, if you will just see, you can just write this one as f of x0, x1, x2, x3. And the third order divided difference for this function, if you will just write, this can be started from x1 to x3, x4 here. And the last divided difference, if we want to write, this can be represented as fourth divided difference, which can be written as f of x0, x1, x2, x3, x4 here. So if the tabular value is just given like xi and yi, so we can just find this divided difference table, and based on this divided difference table data, we can just evaluate this polynomial at any point within this interval using any of the formula like Newton's divided difference formula or any specified formula which can be based on this divided differences. So next we can just show that this divided difference arguments are independent. This means that if we are just considering these arguments here, the arguments can be written in the form of like suppose 3 arguments if we are just writing, or the second order arguments, these arguments can be written in the form of like x0, x1, x2 here. This can be written also as f of x0, x2, x1, and this can also be written in the form of like f of x1, x0, x2. So this can be proved easily, since if you will just see for a first order divided difference, either we can just write f of x0, x1, it can be written as f of x1 minus f of x0 divided by x1 minus x0, or it can be written as f of x0 minus f of x1 divided by x0 minus x1 here. This is nothing but f of x1, x0 here. So similarly, we can just show this independent order of arguments are like independent in a like a divided difference of order 2, order 3, we can just show that one also. So, if you will just go for this like second order divided difference, we can just find that f of x0, x1, x2, it can be written in the form of like f of x1, x2 minus f of x0, x1 divided by x2 minus x0 here. And if I will just take here 1 by x2 minus x0, then it can be written in the form of like f of x2 minus f of x1 divided by x2 minus x1 minus f of x1 minus f of x0 divided by x1 minus x0 here. So, if I will just take common of these terms here, I can just show that 1 minus x2 minus x0, this can be written in the form of like f of x1 minus f of x2 by x1 minus x2 minus f of x0 minus f of x1 by x0 minus x1 there. And obviously, if you will just interchange these signs, we can just write this complete statement as in the form of here f of x0 divided by x0 minus x1, x0 minus x2 plus f of x1 divided by x1 minus x0, x1 minus x2 plus f of x2 divided by x2 minus x0, x2 minus x1 here. So, again interchanging of arguments, it does not affect the solution process also here. Similarly, it can be shown that if you will just consider a nth order divided difference, it can be written in the form of like f of x0, x1 to xn, suppose a n plus 1 terms are there. So, that is why we can just say that this is a nth order divided difference, and it can be written in the form of like f of x0 divided by x0 minus x1 to x0 minus xn plus f of x1 divided by x1 minus x0, x1 minus x2 up to x1 minus xn plus f of xn divided by xn minus x0, xn minus x1 up to xn minus 1 here. Hence, we can just say that these divided differences are symmetric in their arguments. Now, let the arguments be equally spaced, suppose like x1 minus x0 equals to x2 minus x1. Suppose this space size is h here. If it is equally spaced, we can just say that all of these differences, like we can just express x0 minus x1 as h here. So, it can be expressed as h to the power n here. Similarly, f of x1 by h to the power n. So, likewise we can just express the total arguments here. So, if we want to express it in divided difference formula, suppose, then we can just use this one in a form that as f of x equals to f of x0 plus x minus x0 f of x0 x1 plus x minus x0 x minus x1 f of x0 x1 x2 plus up to x minus x0 x minus x1 x minus xn minus 1 f of x0 x1 to xn. So, if we want to prove this formula, that Newton's divided difference interpolation formula here, the statement is if x0 x1 to xn are given set of observations for y0 y1 y2 up to yn are their corresponding values, where the function y equals to f of x is given, then the interpolating polynomial is f of x equals to f of x0 plus x minus x0 f of x0 x1 plus x minus x0 x minus x1 f of x0 x1 x2. So, likewise we can just write this one as x minus x0 x minus x1 to x minus xn minus 1 f of x0 to xn here. So, especially this immediate next term, it can be said to be as the remainder term, where another x value it is required to get this last term there. Since if you will just see here, for the remainder term or the next immediate term, if you will just see, this needs another term here, that is x minus xn here, and it also requires another extra point to get this remainder term for this series to truncate over there. So, if you will just see, it can be written in the product form also here, that is f of x equals to I equals to 0 to n, f of x0 x1 to xi, that can be written as also product of j equals to 0 to I minus 1 x minus xj. And if you will just go for the proof of this divided difference formula here, especially we can just write f of x x0, this can be written in the form of like f of x minus f of x0 divided by x minus x0. Either way you can just write that one, since this order of arguments are independent or symmetrical in nature. So, from these two, if we want to separate f of x, we can just write f of x equals to f of x0 plus x minus x0 f of x x0 here. Similarly, if you will just write, or if we will just add extra more point here like x x0 x1 here, we can just write this one as f of x0 x1, or we can just write as f of x x0 here minus f of, since we are just saying that this is independent of order of arguments, we can write in any forms here. So, f of x0 x1 here divided by x minus x1. And if we will just separate this f of x x0 here, this can be written in the form of f of x0 x1 plus x minus x1 into f of x x0 x1 here. So, if you will just replace this function like f of x x0 in this expansion here, then we can just obtain this expression of f of x as f of x equals to f of x0 plus x minus x0 into f of x0 x1 plus x minus x0 x minus x1 f of x x0 x1 here. So, likewise, if you will just add one more point, finally we can just obtain this formula that can be given as f of x as f of x0 plus x minus x0, f of x0 x1 plus x minus x0 x minus x1, f of x0 x1 x2 plus up to x minus x0 x minus x1 up to x minus xn minus 1 f of x0 x1 to xn plus r of x term, or this complete expansion I can just write here that one as r of x term here. So, if I will just write this r of x term, so like our earlier error term expansion, I can just write this error term as r of x here as x minus x0 x minus x1 to x minus xn, and this term can be, last term can be written as x x0 to xn here, and obviously in a modified form it can be written as x minus x0 x minus x1 to x minus xn f to the power n plus 1 zeta by n plus 1 factorial here, where zeta should be lies between x0 to xn here. So, Newton's divided difference formula also converts to Newton's forward difference formula for equidistant tabular points. So, based on this interpolation formula, we will just solve one problem, that is using this like tabular values that has been given as x as minus 1 0 3 6 7 and f of x is given as 3 minus 6 39 8 22 16 11 here. If you will just use this divided difference, that is like the tabular values as x and f of x, that is minus 1 0 3 then 6, 7, and the f of x values are like 3, minus 6, 39, 822, 16, 11. So, if you will just find the first divided difference here, this means that minus 6 minus 3 by 0 minus of minus 1 here. So, it can just give you the value of minus 9 here. Since minus 6 minus 3, if I will just write this one here, minus 6 minus 3 divided by like 0 minus of minus 1 here. So, that is nothing but minus 9. Similarly, I can just find the difference like 39 minus of minus 6 by 3 minus 0 here, and that will just give you value of 15 here. And if I will just take this next difference here, I can just get that one as 261 here. This means that difference between these two here divided by difference of these two here. Similarly, if I will just take the difference of 1611 minus 822 divided by 7 minus 6 here, I can just obtain this value as 789 here. Next, we will just go for second order divided difference here, that is 15 minus of minus 9 divided by 3 minus of minus 1 here. So, for this one we have to consider like 3 minus of minus 1 here. Second, if I will just consider this divided difference of these two here, 261 minus 15 here, I have to consider the difference of 6 minus 0 here. So, the next one, if I will just consider the difference of 789 minus 261 here, I will just consider the difference of 7 minus 3 here. So, this divided difference is just producing the values like 6 here, then 41, then 132 here. And again, if I will just take the difference 41 minus 6 here, I have to take the difference of 6 minus of minus 1 here. And if I will just take the difference of 132 minus 41 here, I will just take the difference of 7 minus 0 here. So, these values are like 5 and 13 here, that is third order divided difference. And fourth order divided difference, that is 13 minus 5, 7 minus of minus 1 here, that will nothing but the value as 1 here. So, if you will just put in the formula, we can just obtain that one as f of x equals to first value as f of x0 plus x minus x0, f of x0 x1 plus x minus x0 x minus x1, f of x0 x1 x2 plus x minus x0 x minus x1 x minus x2, f of x0 x1 x2 x3 values. So, if I will just put all these values, then it can just provide us like one more point I have to add it up here, since one like 0 value x0 value is this one here, x1 x2 x3 x4 here. So, I have to add one more term here, that is x minus x0 x minus x1 x minus x2 x minus x3, f of x0 x1 x2 x3 x4 here. So, if I will just put all these values, then I can just obtain this polynomial of order 4 here, and the final polynomial as x to the power 4 minus 3x cube plus 5x square minus 6 here. So, if I will just use this divided difference, I can just deal any type of like interpolation formula to get the solutions. So, next class maybe I will just continue for this some advanced interpolation formula, so that I will just discuss in the next lecture. Thank you for listening this lecture.